Good evening, everyone. Welcome back to our basic math class. Okay, just for your information, next week we are not having any class. Okay. Happy. But we might have another additional class, but I think that will be maybe October 21. Maybe I will announce later. But since we are taking starts really slow in our class, okay, I just want to be honest with you. I'm taking really slow this time. And also group 1. Where's group 1? Okay, remember. Every time you have my class in basic math, please sit in between the members. Can you do that? Group 1, group 2, group 3, group 4, all the groups. Okay, please sit well. Okay, because I think we can start with just solving some question first. Okay. Group 5. Okay, group 6. 6 here, 7. Hey, we only have 7, right? Okay. Try to solve this. Okay, try to solve this. You can discuss with your friends for maybe for yes. You have question. Yeah.
He said group 3 and group 4 should introduce themselves.
Oh yes. While you're doing this, where's group 3? Have you introduced yourself?
No. Only one and two.
Hey, I don't see
3, really, right? How about 4? Which one is 4?
3 not yet. This was mine.
I
This guy, what's his name?
think I remember they already did.
I don't remember. It was 1 and 2.
Yeah. Oh, okay. Maybe 3 one more time. Just relax. Just come to the front and then let's say hi to everyone.
eating right now, bro.
Okay, maybe can you do one more time again? Yeah. One more time. And then please say clearly your name, okay? And do not like speak like we cannot hear you. Okay, one more time. So I remember we are having a little bit rush. Okay, group 3. One more time. Come on. Yeah, one more time. I'm forgetting, bro. Again.
Group 1.
Yo, I'm missing one.
Ben.
Yes, yung name ano from Mark.
Yes.
Hello, my name is.
Say it louder.
Hello, my name is Miguel Sander.
Okay. Louder, confident.
Yeah, my name is Celsus Leo. I'm from St. Lucia, that's in the Caribbean. You can Google it.
My name is your IG.
How to call your name? How to call me?
Hello guys, my name is Peter. I'm from Thailand.
I'm Zender, Taiwan.
Okay. Okay, question is find all real solutions. Do you know what that means?
Yeah.
Do you know what that means? So solutions mean that every possible x, that when you are plug in those x inside the equation, it will be satisfied. So you need to find what kind of x that is worked with this expression. Okay. Very nice. I like this answer. Okay, if you can't see, so let me rewrite what he did. So what he did is actually he's trying to restructure the equation. Okay? So he's rewriting the 5x as 6x minus x. So he's writing, let me write. So 3x squared plus 6x minus 2. So this is the first thing he did. Okay? And then next, what he did is he is going to factor some part of the equation. So we're going to see that this is going to be 3x, x plus 2, and minus x plus 2. Okay, and it's very nicely done. Okay, and then after that, first thing, see step by step whether you can process this way or not. Okay, so 3x squared plus 6x, we can rewrite this factor 3x. So we have x plus 2. Okay, and it is x minus 2. It become minus and then take brackets x plus 2. Okay, so we see that, okay, it's correct, right? And after this, what's happened next is we are going to factorize this x plus 2. So factorize this x plus 2. Okay? This is what he did. So x plus 2 factor out. And we are having nicely factors. Okay? Oh. Right? Yeah. So sometimes you could do this for some kind of equations. If you can think some numbers like this 6x and negative x like that, and it's nicely done with the x plus 2 here, and we can factor out x plus 2. Okay? Or usually my method for this one is trying to factors. Okay, trying to factors. Let me use different color. So try to factor directly. And giving the table like that. So this is 3x, x, the only possible way, right? And then we have negative 2. So either 1, negative 2, or negative 1 and 2, right? Or maybe you can switch that also. But since we have 3x here, then we need to think what kind of number that we should have. So if we take, maybe just write the numbers first. So maybe 1 and 2. And we can think the sign later. Okay? We see this is 6x. This is already positive. We need to minus 1 to get 5. And this is perfectly 1 here. So negative going to be here. Okay? And we give negative like that. So we have, from here we get 3x minus 1, x plus 2. The same result. So x will be negative 2 and x will be 1 over 3. That is the all real solutions. So x 1 over 3 and x is negative 2. Okay. Either way, that's correct. Okay? But I like this answer. It's structurally nicely factorization, nicely factor out. Or if you want, you can try the quadratic formula. See the b squared. Okay, you can minus b plus minus square root of the b squared minus 4ac over 2a. For some cases that is usually helpful, but for other cases that maybe just trying to change the expression is maybe more easy to be solved. Okay, try number 2. Try number 2. Number 2? Okay. Okay, you can try over here. Okay, try number 2. Wait. Maybe sometimes the answer is not perfect numbers, like the whole numbers. Maybe it has some irrational. That's okay. Oh, this one. The blue one?
Yeah, the blue one.
But this is negative.
Oh, this one?
It's supposed to be negative.
You have x plus 2, factor out. Bring out your x, minus 1. Okay. Yeah. Just solve things. Just do. Okay. And then there we use the formula. So for the whole semester, I would like to at least for everyone try at least one time to solve some problems in the board. At least once. At least once. Okay, very good. Yeah, you can send it to one.
Creo que se fue un poco demasiado. ¿Qué nos indicaron el primer reunión? Bueno, vamos a ver.
Okay. Yeah, I think solutions are correct. You can solve until here, or maybe you would like to simplify more. That's still okay, but up till here, I believe is already fine solution. Okay. So the idea is we need to remove the denominator. We only care about the real solution, which means that we just need to multiply all, right, with the same common factors, which is the x squared minus x, or if you still write x minus 1 and then write here, still okay. So multiply this and then solve the equations. Okay. So we are only care finding the real solution. So sometimes some problem might have, like for example, the last time we have the inequality, right? We have the inequality. For inequality, sometimes multiplying directly not work because we don't know the sign. Okay? It can be, if it's negative, we can change the sign, right? But since this is only like equal, we can do this process. Okay? So we can do this process easily. Okay? And I think after you get this, you could directly write the quadratic formula, or if you want to complete the square, you could do that as well. Okay. Okay, I think it's correct. Number 3. Okay. Okay, maybe. Maybe using Roman to make sure that different comes. Okay, number 3, we have absolute value. What's the implication of absolute value? It means that all the x or all the anything inside this absolute value can be positive or negative. Because it's resulting in the final product that is positive. Okay. So either we have 2x minus 5 equal 9, or we have 2x minus 5 equal negative 9. So every process in math, whenever you need to try to confirm, okay, and maybe convince that, okay, this is the correct way, you can try some number, or try the solution. So you already have solution, you can put back the solution and whether see if it works or not. Okay, that's one way to confirm. Okay, it's correct. So, right. Yeah, you can give applause. So 2x minus 5 equals 9, or 2x minus 5 equals negative 9. And then we can solve this. The first one is 7, the second one is negative 2. If we want to try, we can try plug in 7 here, 14 minus 5, of course 9. We can plug in another one here, which is negative 2. We try to negative 4, negative 5, and negative 9, and then absolute value becomes positive 9. So it's true, right? It's correct. So that's how we can convince ourselves that we are getting the correct answer. Okay. So every time, like usually, if you read questions, maybe in calculus, in mathematics in general, sometimes the questions give you some condition. Now you need to think about the condition. Like, for example, in calculus, okay, the function continues, blah, 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 blah. That is the condition. Okay, that you need to think, okay, what is the implication of that condition? And then you need to apply maybe some rules that related to that. And when you solve, then you can write your process in a structured way. Okay? And that way also, I can understand better what you want to do in the solution. Okay. So I think this is okay. Let me continue. Okay, let me continue for a while. Just maybe a quick review on the inequality, and then we can move on to another subject. Okay. Okay, I think we can move to our notes here. Okay. So absolute value inequality. So because we finished our last exercise with absolute value, we can do the absolute value with the inequality. Okay? The idea is still the same, which means that x can be positive, can be negative. Okay? And then we can also write the interval because we are in the inequality. Or if we have the greater than constant, it means that the x is less negative c, or the x is greater than c. Okay. Okay, you will see more on the absolute value when we learn functions that is related to absolute value. Okay. I think in general, what this inequality wants from you is to have a solution in terms of interval. In the previous one, just find all the solutions because they are just like exact one solution, or maybe some solution, several solutions, right? But in inequality, sometimes you need to find the interval where the solutions are true or correct. Okay? So this is the property of absolute value inequalities. Okay, now let me explain just for a bit how do we use it. So for example, if we want to solve, okay, we want to solve this. Absolute value x minus 5 less than 2. And whatever the signs here, less or greater, if you feel confused, okay, do not worry about the signs first. Okay? I don't want you to memorize, okay, if you have this, then okay, maybe the interval will be here and here. Unless you are getting used to it. But for now, what I want you to do is not to memorize, but is to check like usual. Make it equal. Okay, make it equal. So let's say we have this. Just make it equal first, okay? We want to know which points, okay, from these equations. So first we have that this will be positive, and we have that this is negative. And for the positive one, we get that this will be 7. And for the negative one here, we get that 5 minus 2 is 3. So we get 2 points, 3 and 7. So from these 2 points, as I mentioned, I think many times, draw a line number. And put 3 and 7. Three, 7. Okay, we take some number here, here, and here, and check to our whole equation. Okay. Okay, let's say we have, say 0. We put 0 over there. This becomes negative 5. It becomes positive 5. 5 less than 2. Is it okay? 5 less than 2. No, right? Okay, we move on. We try to meet in between. We try 4. 4 minus 5, negative 1. It's become 1. 1 is less than 2? Correct, right? If you are not convinced, try another number here, maybe 5. 5 minus 5 is 0. 0 is less than 2. So I think 2 is already correct. So I think this will be solution, right? So this is our solution. So solution is on the open interval of 3 and 7. Okay. If you're getting used to this many times, you could skip this and just write on the right side. I will write here. You can skip this part and then just write here negative 2, x minus 5, negative 2, positive 2, and then solve both of equations, both of expressions. So we get this will be 3, x, and 7. Directly get the answer. Okay. But if somehow you're still taking step by step, taking the baby step, just make it right alignment. are already familiar or really know how to do, just skip this and then go here directly. That's okay. But if you want to convince that your answer is correct, then I suggest is follow this. Find the points first, and then try the interval. Okay, just to make sure that we did the right thing.
Okay, another one maybe solve 3x plus 2 greater or equal 4.
The idea is still the same. First, if you're not knowing how to directly go to there, then you find the points, use the line numbers. The line numbers will be really useful even in calculus or even in the engineering of mathematics in the future.
Yes?
Go back to the rules again. I didn't.
Oh, you mean this one?
Yeah, yeah.
Okay, you can check this one.
You can pretend this is equal first, and then check the number, and then you get the confirmation. Okay, that's okay. Yes. Okay.
Okay, so let's try the second one. So as usual, we could check the point first. Let me just write it like that. So we get that this will be 2/3, the first x, and we have the second one, which is the -2. So again, we put those numbers. And since they are both now includes, we need to set up a close interval, right? So this is the -2, and this one is 2/3. Okay, maybe we can check the middle one. Check the middle one, let's say 0. I think 0 is easy, right?
0, 2, greater 4. It doesn't make sense, right? Maybe not in the middle. So check -3. I think it's okay. Put
So let me write here check.
check x equals 0. It doesn't make sense. -3, let's say -3.
Actually, any numbers that is still within the interval. This is okay. So x maybe -3.
I think it will be -9 plus 2 is -7. With the absolute value becomes 7. 7 is greater than 4. It's fit, right? And for sure, I think this will be also fit. So try 1. 3 plus 2 is 5. So 5 is greater than 4. So we have from this interval and this interval. So interval on the left and right. Okay?
So this is our solutions. So we can write the solutions. Or if you want to write in terms of x, we can write x or x is greater or equal to 2/3. Okay.
Or if you prefer to write,
Or maybe to think, for example, you have 3x plus 2, let's say greater of 4. Okay, you solve this and then you get that this is true, and you write the same thing, but now for -4. But because we multiply with -1, the inequality becomes changing like that. Okay. This is also okay if you prefer this. And you get directly the answer.
get the answer. Whenever you choose, I think still okay. For me, if you want to make sure that your answer is true, you can check the line. That's the slowest one to confirm. If you're already familiar, you already know how to present in your mind, you could skip and then just getting the final answer. I think it's still okay. Okay, any questions? Any questions? No? Okay.
Okay. Okay, now we need to move to the next section. So we move from the inequality to the next section. Okay, the next section is about actually a complex number, but I will skip that for a while. Let's go to the coordinate planes, so graph of equations and circles.
Okay. So I will do some quick review. So we have we call this Cartesian. Okay? We call this type of coordinates, we call it Cartesian. What's the meaning of Cartesian? Point by point coordinate. It means that you can cut into pieces these all coordinates in terms of this small rectangle. We call that Cartesian. Another form of the system is we call the polar system, which we cut into pieces, not rectangle but circle. Okay. We are going to not to discuss about polar, but maybe later if we have time. So for now, I would like to focus on the Cartesian. Okay. Sometimes we divide. We do this for we call the quadrants. Okay. It has 4, so the one section is called quadrant. the first quadrant, second, the third, and the fourth. This quadrant also giving you some sense of understanding when you learn trigonometry. That will be for, I think, next lesson for trigonometry. But just to make sure that how we set up the system, so we start from 1, which x and y is all positive. 2, y is positive, x is negative. And 3, all negative. And 4, x positive and y negative. Okay, we set usually using this 1, 2, 3, 4. Okay. So by default, this is the system. And then how do we set up the point? So we set up the point based on the x, y position. Okay. So we write x, y, for example, negative 2 and 2 here, 1 and 3, and so forth and so on. Okay, just a quick introduction.
And from here, we could also make some simple graph. Okay, some simple graph for just to make sure that we understand. If I write x equal 1, okay, where should I put this x equal 1? Yes. So we see on the x-axis, we get 1, and it means that we doesn't specify y, right, by values. It means for every y values, the x equal 1, which means that it's going to be a vertical line. Okay, agree? So this will be x equal 1. Let me just write here. Okay. It's actually from the top to bottom, but I just write like that. Okay, I hope you understand. And then we can also have his friend, maybe y. Okay, let's say y equal 1. It means that this is going to be the horizontal one. Okay.
Especially in calculus, you will see a lot this x equal 1, y equal 1, or the other vertical or horizontal line when you learn about the asymptote. When you learn about limit, you will see a lot this type of line. Okay.
And what is if I say x greater equal 1?
What can we do in the graph? It means that it needs to cover all area. Right? From this x equal 1, why I'm writing x equal 3.
Oh, no one pay attention. Too sleepy.
Okay, so if I have x greater equal 1, it means that all area on the right side is included within this. Okay?
So we can say this area, all area here is included. Okay? And what if, let's say, y using absolute value and less than 1?
If you get your inequality correct, this should give you negative 1, less y, less positive 1. Right? But remember, it's not equal. It means that sometimes we need to draw the line with the.
So let me draw for you. So I hope you don't mind. I will erase this part. I hope you get your notes correct. Okay. So let me erase this part for a while, just to explain this y. Okay. So let me use green color. So y is in between negative 1 and 1. So negative 1 is here. And 1 is here. Okay, let me use dash line like this. And then area will be here. So we're usually using the dash
type of line like this to express that this is not including this y equal. Okay? So it's in between. Okay? It's open interval. Open interval.
So this red color is y less than 1. Absolute value of y. Okay. If we are going to include 1 in equation, which means less equal, this green color will be full line. Make it full line. Okay. Okay, what else can we do from this condition, from this position? What can we do from this position here? We can compute the distance, right? How to compute the distance? Let's say I want to compute this -3, -2, and 2, -4. Can we compute the distance? Yeah, how? Okay, the easiest one, if you are in the exam, and the exam, if the exam is designed by mathematicians or maybe the government using the basic proportion in mathematics, bring your ruler and you can measure the distance. It's true, it's true. I usually using this method just to confirm my solution. Sometimes the question, the curve, they will draw the curve with a good proportions that you can measure with your distance, with the ruler. That's one thing. But of course, that is not what we're going to solve here. So the idea is, okay, let's just draw the line. Okay, draw the line. Draw the line. Okay, that's the one that we are going to measure.
And we have something here. Anyone remember how to measure this? Besides using ruler. Anyone remember? Yeah. Yes. Yeah. Yes, square root of. Okay. Yes. What do you say?
It's the Pythagorean. I don't know
Yeah.
how to pronounce it.
Yeah, Pythagorean. Okay, Pythagorean. So again, you know, okay, this distance between 2 points. How?
Okay.
So I need you to think logically. What we can do from here? Okay, let's draw another line here. Okay.
Okay, let's draw another line here. And draw another line there.
And we know we are living in Cartesian. All Cartesian, if you cut into pieces, is a rectangle. And rectangle is made up of 2 triangles. And of course, it will be the right triangle. The right triangle, okay? So it's a right triangle, but actually I didn't make it right.
Maybe let me correct this one. Let me make it a little bit clear. Okay, so right triangle.
Which means that we can take this square plus this square equal to this square. Okay. Can we measure this? Can, right? This is what? 2, right? This, where's the 0? 0 is here. 0, 1, 2. Yeah, 1, 2. Oh yeah, we can just use the 2, and then 1, 2, 3, 4, 5. 5 squared plus 2 squared equal that
Distance squared. So let's use this is d. So this is 2, this is 5. Okay? So d squared is 2 squared plus 5 squared, which is not a nice number, but let me just write that. So d will be square root of 29.
Of course, since we are measuring the distance, The only possible value for the square root is positive. Okay? If it's negative, what kind of distance that has negative, right? Doesn't make sense. So positive. Okay? Okay, get it? Get it? Okay. So everything are connected. Okay? Everything are connected. So in mathematics, it doesn't need to be like, okay, new chapter, okay, new formula, okay, I need to memorize this. No. Everything they are derived from anything that you have learned before.
So when I give you this, let me go to the next slide. It seems so complicated, but it's actually just Pythagorean theorem, okay? It's just Pythagorean theorem, okay? So not remembering this. What you need to remember is you have a triangle. You have this square plus that square and equal to d squared. Okay? Now when you read this, it becomes more easy, right? Yeah, perhaps maybe some. I must honest because I also experience like learning math in some way. Most of the teachers they do not know how to teach math. Yeah, I need to be honest. And sometimes you are giving like information without knowing why we need that one, why we need that one. They just write in the front and then we need to write down, we need to solve this act, blah blah blah. Without even knowing like what's the implication in our life. Okay, I think this distance formula. So what I want actually in the class is not about like how much note you write, but how much note you write that you understand. Okay? If you just write it, but you don't know what you are writing, then that means that the problem is the understanding. Okay, distance formula. So maybe just notes here. What is Pythagorean of not pH, Pythagorean theorem. Okay, let me just write here, make it small. A, B, C. So C squared is equal A squared plus B squared. Okay, one of the oldest mathematics relations that we learn, I think.
If we know the distance, can we know the middle point of that distance? Can we know the middle point? You just divide by 2 easily.
So we could write also. So if we have, okay, let me write here. So the midpoint, I think the midpoint, let me just write here. I forgot to mention the copy. So maybe let me write midpoint of line segment from A to B. It can be in any x or y. Is equal x1 plus x2 divided by 2, right? And then y1, y2 divided by 2. It means that it will be on the midpoint. Okay? Maybe let me add in the picture, this is the midpoint. Let's say that is equal. Okay.
Okay, now we know the Cartesian, we know the 4 quadrants, we know the distance, we know the midpoints. Okay, now how to graph? Okay, how to graph?
Let me write here. Sketch the graph two x minus y equal 3. Okay, I would like to know how would you like to do this. Okay. This is the linear equation, 2x minus y equals 3. Okay, I would like to know how you are going to do this sketching.
Oh.
Okay. Can you try? I would like to see how the process. One way is try x equals 0, right? Y equals 0, right? That's one way. Oh, I just knew that we have that one.
Yeah, we were like, what? We came in from the back and there's a TV.
No.
It's different from that one too.
Oh yeah, it's actually mirror from my screen. But that one is like the conventional one. Of course, the books will give you like the process from the early stage of your learning.
Yeah, that's good.
But I don't think that is good for you. I will just give you like the best way to draw this. So if you look at this one here, so if you would like to sketch this, so if we write in terms of y, we are getting 2x minus 3. Okay. Now because we don't give you like we are not starting yet as a function, right? But I think some of you already know the function, right? So let's say we take this as a function. So the only variable that we can exchange is the x, right? So we can check x from 0, from -1, -2, any x, and then check the y value. So you can get points by points. But that will be troublesome if you are in the exam and then you need to compare this graph with another graph, or maybe you need to draw the more complicated one. So what's the best way? The best way is if we take x equals 0 or y equals 0. Okay. So this way you will know that when x equals 0, y is equal to -2. And what is that? Okay, let's try to put into the graphs. So first we take x equals 0. This will give you y equal -3. Y equals 0 will give you 2x equal 3, or 3/2. So where is y equal -3? -3 is on the below here. So we take 1, 2, 3, and then we take 1, 2.
Okay. We call this the intercept. Okay. So when x equals 0, y equals -3, between that will be the y-intercept. It means that the line will cross this y. It's called the y-intercept.
Okay, so let me write. This is y-intercept. This is the x-intercept. So then you could
Connect this two. Connect this -3 to 3/2 is 1.5 here, around here.
So let me write down here and there, and then connect these two.
Another way to look at the linear equation is by the gradient or the slope,
Which I think I will going to give you next time. Okay. You could also remember, if you remember the linear equations, the general formula will be y equal mx plus c, right? Plus a constant. This is linear equations. And what is m? What is c?
M is we call the slope or the gradient. Okay. So let me
Right here, this is the gradient. And sometimes we just write the gradient as, for the linear equation, okay? So we say this. Or sometimes we just make it easier, so delta y equal over delta x.
What is delta y? What is delta x? It's precisely here.
So we get this triangle. So again, we get the triangle, this one here. And let's say this is the point x to y2. Let's say, oh, this is the x1, y1.
So we can get this slope, or we call it gradient, from this to delta y and delta x to get m. Now, of course, if you see from this point here, because we already know the point is -3, and this is 3/2, we can get a sense that this will be -3, and this will be what? 3/2. So we get that.
So, but how do we write the gradient here? So y2 is 0, so 3, so 0 minus 3. And then x is 3 over 2 minus 0. So this will be equal to,
Which is precisely that the line that we have, it's
2x, right? So let me write again that this is 2x.
So we get the gradient equal to, and then you can write, so if we haven't yet getting this c, we can write this to,
Put inside the equations y equal mx plus c. So we could write, let me write here, so y 2x plus c. So what we do now?
we put the point, either x1, y1 or x2, y2, we put inside here and we get the c. Okay.
So let's say we take what? 0, negative 3. So let's say 0, negative 3, 0 plus c, because it's getting c negative 3. Okay.
So we get all the things that we start with, right? Okay. I'm writing like forward and backward just to prove that we can also approach with linear equations and finding the gradient. Or if you want to just draw, I believe using the intercept is the fastest way to draw. Because you only think what point that crossing y and what point is crossing x, because you only have this line here. So either horizontal or vertical, our only choices is like this, right? That has the some gradient, okay? So it must be crossing x and y, right? It must be. And to give you more context about all the terms, so that you are not really, you don't need to like memorizing everything. So if I have this triangle.
Let me redraw the triangle. Maybe make it clear. Okay, let's say this is a triangle. Okay, let's say we have an angle here. Okay, and let's say this is y delta x.
If I say tangent theta, what is tangent theta? From this triangle here, the small one here. So y over delta x. The same, right? It's also, in calculus, we see the tangent. It's the same. They're the same thing with different terms. They're the same. So no need to like adding more terms that need to be defined. But you see that we know this as the tangent and we know this is also the gradient. So they are the same thing. Okay. So from here I go everywhere and I go to trigonometry, some linear equation. Okay, any questions? No? Okay.
I think quite good. Okay, maybe just review the intercepts. Okay.
There's blah 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 blah. I don't want you to write this. I don't want you to write this. Okay. Just read. This is what we have done previously. Okay. We set y equals 0 to find the x-intercept. We find the x equals 0 to find the y-intercept, which means we are finding the one that is crossing by our curve. Okay. So that's the idea.
So that's why when we have
quadratic equations. When we find the roots of that, or find the solution, if it is equal to 0, it means that we are getting in the x-axis we are getting the crossing points, right? Okay.
Okay, I think we can move to, after this one, we move to a little bit to circle. Circle. Okay, let's move to circle. So this is the definition first. So let's say we have,
Okay, let's say we have our Cartesians, okay, and a circle, like a full circle, just random circle, and we have points C and P, okay, and both of them have a coordinates. They both have a coordinates, okay. Okay, and then this distance is R. Remember the distance between 2 points? If you forget, it's draw triangle.
so drawing here, drawing there. Okay, we get another triangle.
Use the Pythagorean. This r squared is equal to this one squared plus this one squared. And we need just to mention what is this and this, the delta y and the delta x. So here is the x, here's the x. So this will be x minus h, right? And this will be y minus k, alright?
So this one is, let me write. This one is x minus h. I'm just putting the absolute value to make sure that this is a distance. So we get the from Pythagorean that the r squared equal, maybe write x first. Or we could set up the square root of this two. And remember,
In this circle, the radius will be positive, right? So the only way that this is correct is if this is positive. It can be positive, negative, but we choose the positive. So we define the radius as something that is positive. This h and k becomes the center. Okay? So it depends on this h and k becomes the center. So if
we have these equations, then the center is hk. So r is radius of the circle, right?
So if we move the center to this origin point, then we set the h and k 0 and 0. So we get r squared, x squared plus y squared. Okay.
So we get at center 0, 0, we get that this is going to be the equations.
which implies that every time you see this structure or this structure, then you know that it will be circle equations. And even you could also try to sketch or draw the circle. Okay? You know the exact equation. For example, maybe x squared plus y squared equals 16. That would be a circle with radius equal to 4. Right? Okay? Yeah. Let me just write over there. Okay.
So if we have x squared plus y squared equals 16, this will be a circle, radius 4, and the center is 0, 0. And if we have, for me, example, x minus 1 squared plus y plus 2 equal 4. R is 2. Center is what? Center is?
What is the center?
1 minus 2.
1 minus 2. Okay. 1 minus 2.
So sometimes
The questions regarding the circle is finding the circle equation, or perhaps maybe finding the radius, finding the center, or even maybe drawing the circle. Okay.
okay, this is just same notes what we have done before.
So this one called the standard form, using the h and k definition. X minus h squared, y minus k squared equal r squared. That's the standard form of circle.
So let me give you some sort of examples. So let's say find equation of circle that has radius three and center -2, 5. Okay, directly we can just put into our h and k, right? So remember this is h, k, the center, which means that the r is 3, which means r squared is 9. So we can write, or maybe let me write x plus 2 squared plus y minus 5 squared equal 9. Okay? Right? Let me put some other example as well. So find equation of circle that has points, let's say P, and Q, as the endpoints of the diameter. Okay.
Can you show the formula to find the center?
The
Yeah, just show the center.
or the top one.
Yeah.
Okay. Here.
Professor. Like how to find the center?
Oh. You can read this one also. An equation of circle with center h k means that this one is h k inside the equation.
Yeah.
When you say this, and the endpoint of the diameter,
Yeah.
what does it mean?
So it means that this p and q are on the endpoints of the diameter.
Okay.
Okay. Yeah.
Okay, can you try to do this second question here?
Okay, so what does it mean? So it means that the P and Q, if we take some sort of line between P and Q, that will be the diameter. Which means the radius is half of that. Which means that is the midpoint. So midpoint will be 1 plus 5 divided by 2. That will be 3. 8 minus 6 divided by 2. That will be 1. 2, yeah, 1. So 3, 1. That is center. Did you get it? You get it?
So let me write here. Okay, let me write here. So the midpoint. So let me make some statement here. So the midpoint PQ is the center of the circle, right? So the midpoint PQ is 1 plus 5 divided by 2, and then 8 minus 6 divided by 2. Or this will be 3, 1. And then the distance, how much the length will be. We can check the distance PQ is square root of or maybe not distance PQ. Let me just go through the R to get directly the answer. Sorry. So the R squared is, I will using the P and the midpoint. So the P and the midpoint. Okay. So 3 minus 1 squared plus 1 minus 8 squared. So R squared will be 4 plus 49. Okay, for 53. So circle equation is x minus 3 squared plus y minus 1 squared equal 53. Or maybe let me explain why I get this r squared is equal. So radius, take the P to midpoint, or take Q to midpoint. For example, if we take Q, then we have R squared 5 minus 3 squared plus -6 minus 1 squared, which is the same. This will be 4 plus 49, which is 53.
Okay. So we could take P to the midpoint or Q to the midpoint. Or if you would like, maybe you can check this, the fall distance, and divide by 2, that would be radius. Also okay. Because the distance PQ is the diameter. Divide by 2, that will be radius. Okay, let me get through this simple equation and let me rewrite this in the numerator. Okay, any questions? Any questions? Any questions? No.
Wait, sir, have you found it traditionally, like for the radius, the distance between the center and like one of the points?
You mean through the distance, PQ, or?
Yeah. Just like
Yeah, the same. Should be the same. But why? Because in the distance, when you try to find when the numbers maybe not really, maybe it's like a good, like not really a good numbers. Sometimes you will make some mistake. So I make sure that we get directly to the radius. If I take the distance, like I write before, I get the diameter. But then the diameter is still in the square, right? So instead of divide by 2, we divide by 4. Sometimes you forget this 2 and 4. I just avoid that.
Okay, let me copy this part, the circle equation here. So we are still like writing this as our standard for circle. But if we expand this x and expand this y within this square, we can also rewrite in the non-standard form. Let me write in the next one. So let's say this is our circle equations. Okay. So if we expand this, for example, we can take this. Okay, and then we are going to take all the constant, we simplify. So this will be equal to 43. Okay. Now we need to think, if we are given this, okay, we are given this equation here. Can we make it into this one? What should you do if you want to make from this equation back to the standard form?
after.
Huh? Yeah. Any idea? Yeah. Not really that. Yes, complete the square, perfect square. Okay.
Why did you write 43?
One minus
Huh?
Why did you write 43 instead of this one? Oh.
It's okay. Okay. Is correct, right? Oh. Okay. Now, if you want to write making this standard form, we need to take the perfect square, okay, to complete the square. Okay. So how to do that? So first, because it's already in the x and y,
So x squared minus 6x, and then plus, oh, let me write with the color, red color. It's plus 9, okay? And then let me write here, because with plus 9 on the left, we need to plus 9 on the right, okay? And then we plus y squared minus 2y. What we need to plus here? Yes, plus 1. So we need to plus 1. Okay? Plus on the left, plus on the right. Okay? So this will be x minus 3, right? Okay? And plus y minus 1. And this will be, okay, back to the first one. Understand? Do you need more examples? Let me give you examples, something like this, okay? Okay, let's say we have x squared plus y squared plus 2x minus 6y plus 7 equals 0. The question is find center and radius. Okay, how to find the center and radius? Basically, as we mentioned I think earlier from the circle equation at the beginning, as long as we can find the standard form, the h, k, the center, and then the other one on the other side will be the radius squared, right? R squared. So as long as we can make it into standard form, then we can find center and radius. Okay? Okay. And we're still not getting used to the complete square or the perfect square. Okay, that's okay. You also take it, yes. More later. Need to take that with you fast. Yeah, if you plus on the left, you plus on the right. You have to make the equation balance. If not, then you are changing the equation, right?
Wait, the radius is root 3. Is the radius root 3?
Root 3? Maybe. I think maybe. Plus 1.
Plus r squared is
5. Yeah, maybe.
because it's like r squared is 3.
Yeah, so yeah, that's you're right.
Say negative 1x.
Because we got 3 extra, and because I added 10 to the next levels. Is this y minus 3? Yeah, minus 3. That's minus 3. Minus 3. If it's minus then.
Okay, I think most of you, I think some of you are already getting used to this. So we can write this. First, we group all the x. And let me add some distance. And then put the negative 7 on the right. And then basically what we did on the complete square, we take some from this 2x, we divide by 2, then take square. So divide by 2 is 1, squared is just 1, so plus 1. Okay. So we plus 1. Plus 1 on the left, plus 1 on the right. Okay, don't forget that. Okay, you need to make it balanced. And then the 6 divided by 2 is 3. 3 squared is 9. So we need to plus 9 here and plus 9 there. Okay. And then we can complete this by taking this as that, and y will be this. Okay. And then this will be 3. So center is negative 1, 3, and radius is square root of 3.
I didn't understand where the 1 and 9 come from. Wait, it's not that 2x minus cy. It's 6.
6, 1, 6, 1.
Ah, it's okay.
Oh. Oh, yeah. Sorry.
No, it has 6, it's not a B. Oh, makes sense.
Okay.
Yes.
And the 1 and 9, Professor?
Yes.
The 1 and 9, why we choose those numbers?
This 1
Yeah.
is coming from this 2, divide by 2, and it's squared. Plus 1. So I think the best way to make this make sense.
Wait, is the radius right?
Yeah.
Shouldn't it be like 3 squared? So 9.
No, it's already squared, right? Already squared. Okay. So I think if you are maybe not sure how to get this 1 and 9 and why we did that and why you are doing that, it's actually, so if you let me give you, let me just skip this for a while. So if I have x squared plus 2x, okay? So I would like to build something from this, which is I will have this x add or plus or minus something, then when we square it will go to this. Let's say we take plus a. Let's plus a. Okay, we have x squared plus 2ax and then plus a squared. Okay. Now we would like to make this ax become this 2, which means that maybe a is 1. Or maybe this is just 1. And we get perfect square, so that's why we do plus 1. But the easiest, the shortcut is divide by 2 and then square. Okay. It's actually from this formula, from this expansion. But we have 2 in the front. That's why we divide by 2 and then square. Okay? That's how we get it. So to end this lecture for today's class, I would like to do some post tests. To do some post tests. So I think next week we can. Oh, next week no class. Next 2 weeks, we could go to functions and some review on functions. Just a quick review because we also have in calculus. So let's take a review and maybe some function that it will be for almost the time you will encounter that function, like exponent, logarithm, and so on. Okay. So let's go to the post test. Okay. So this time, the test will be based on you. Okay? So I will just give the link, but I haven't checked. But let me try. Okay. Or do you want to have the QR? Maybe QR. Okay, QR. Maybe faster. Go here. Use name. Your name need to be your student ID. Okay. So use your student ID as your name. Okay. Student ID. Okay. If not, then if you will be using another name that I will not recognize, then I cannot grade you or maybe add some points to you. So use your student ID will be better.
I know this. Sir, you told us to introduce ourselves, but you still assign us by our names.
It's for grading. Okay, for grading. Okay.
Oh, we can start first. No, it's our
Okay, already? You already joined? Okay. I hope everyone already joined. Okay. Oh. Okay. I think you guys ready, right?
No.
Huh? Okay. Oh. Look up your screen. The screen. So this is based on what you can do. Okay. So if you are finished, then you can finish early. Okay. So we are not going to do the countdown. And maybe this is distracting. This is like the leaderboard. Like, you want to make this like a competition, you could do it by your own also. People have like clubs, activities, you want to play games, you have to using this. Quizzes, easy to play. The website also good. Having a good UI. Okay. Okay, remember if it is asking the number, please write only the number. Do not write maybe it's asked like function. Do not write f equals some numbers. Okay, just write the numbers. Okay.
Where you freeze ahead?
Oh,
I don't know. It's what?
everything wants to be finished, right?
Okay, finish. That's okay. Okay. You finish, right? Bro, you finish? You done? Yeah, bro. Go. Okay. Okay. Any other student finish? No? Yes, yes. Yeah.
Professor,
Yeah.
sure.
Yeah, I think if you finish already, you can keep packing your stuff. And... Okay, good, good.
I think this is not. This one. This one.
Yeah, you can go, you can go. You can go.
Damn, we got 6,000.
Okay,